Okay, this problem concerns the difference between pairwise independent and independent. Alright, so event A, let's figure out the probability of event A. What's the probability of event A? Well, A happens if Mo and Larry both roll the same number. So if you have a fair die, that's chance I equals 1 to 6. Probability that Mo rolls I times the probability that Larry rolls I. So they both roll 1, or they both roll 2, or they both roll 3, and so on. So that's equal to the probability that I equals 1 to 6. So summation I equals 1 to 6. The chance that Mo rolls any number is 1/6. The same for Larry, 1/6. So I've got the same number, 1 over 36, being added together 6 times. And so the chance that Mo and Larry roll the same number is 1 out of 6. And by the same logic, the chance that Mo and Curly roll the same number is 1 out of 6. And the chance that Larry and Curly roll the same number is also 1 out of 6, by the exact same logic that I'm not going to rewrite. Okay, so to show that they're pairwise independent, let's figure out the probability of A and B. What's the probability that A happens and B happens? So Mo rolls the same number as Larry, that's A, and B, Mo rolls the same number as Curly. And so therefore, Mo, Larry, and Curly all roll the same number. So that's the probability that I equals 1 to 6. The probability that Mo rolls a number, and the probability that Larry rolls the same number, and Curly rolls the same number. And by the same logic as we did over here, that's a summation I equals 1 to 6 of 1 over 6 to the third. 1 over 6 times a 6 times a sixth. So that's 6 times 1 over 6 to the third, which is 1 out of 36. Now, very conveniently, we see that probability of A and B is the same thing as the probability of A times the probability of B. And so therefore, A and B are independent. Similarly, by the exact same logic, the probability of A and C also works out to be 1 over 36. And so the probability of A and C is the same as the probability of A times the probability of C. And the probability of B and C is the probability of B times the probability of C. So all this shows that A, B, and C are pairwise independent. Because these three things hold. Okay, so A, B, and C are pairwise independent. But what's the probability of A and B and C? Well, this says that Mo and Larry roll the same number. B says that Mo and Curly roll the same number. And C says Larry and Curly roll the same number. So if all three of these things happen, that means that the three people all roll the same number. Well, the chance that all three people roll the same number, we just figured that out. That's 1 over 36. So the probability of A and B is exactly the same thing as the probability of A and B and C. Now, clearly, that is not equal to the probability of A times the probability of B times the probability of C. So this is an example where these three events taken 2 at a time are independent. So but if I take them 3 at a time, this product fails. So A, B, and C are not independent. So this is an example where we have events that are pairwise independent but are not independent.